Welcome to this online revision session for AQA M2, which we'll be considering the January 2010 question 8 involving energies. So what we have here is a bungee jumper of mass 49 kilograms is attached to the end of a light elastic cord of length 22 meters. And its modulus of elasticity is 1078, and the bungee jumper stands on a platform and falls down towards the ground 60 meters below, and the distance that the bungee jumper falls is x meters. So the bungee jumper has fallen down to this point here. So this is x meters down. Then the cord has a length of 22 meters. And then once it's fallen beyond 22 meters, this now extends. So the extension in here will be x minus 22 meters. And it says, when considering x is greater than 22 meters, by considering energies we've got to find this expression. So what do we need? Well, we need some energies to be considered. So we have at the top of the platform, so if we call the top of the platform is the initial position, so initially the kinetic energy will be 0, and we'll take the gravitational potential energy to also be 0. Then the kinetic energy at the point to which they've fallen will be equal to a half the mass, which is 49, times whatever the velocity is at this point, so whatever v is at this point, squared. Then the gravitational potential energy will be negative the mass, which is 49, times the gravity times the distance which has been fallen, which is x. And then we've also got elastic potential energy. Now for the first 22 meters the elastic potential energy is 0. And then the elastic potential energy at the point to which we've fallen is x will be given by, if you remember, it's a half lambda e squared, that's the extension squared, over the twice the natural length. So modulus of elasticity lambda is 1078. The extension is not x, but it's x minus 22, so that has to be squared, all over the natural length, which is 22, and that has to be multiplied by 2, because remember it's over 2L. Okay, now we know that the sum of those energies on the right hand side, the initials, must equal the final, so by conservation of energy we have the following. we have 49 over 2 v squared minus 49 gx plus, well, it's 1078 over 44 multiplied by x minus 22 squared, and that has to equal 0. So we need to do a bit of rearranging, simplifying, and then we should be alright. So what should we do first? Well, we can get the fact that v squared will equal 2gx minus, because we're taking that across to the other side. Let's just get this the right way around. Yeah, so looking at that, yeah, when we take this part here, the 1078 over 44, and we multiply it by 2 and divide by 49, 49 just happens to go into 1078 22 times. Times the 2 makes 44, so that cancels out the 44, and so we are left with x minus 22 squared. So now we can multiply through by 5 to get the 5v squared, and then we can expand these brackets. G we can take as 9.8, so this becomes 19.6, which when multiplied by 5 gives you 98x. And then from this other bracket we will get plus another 44x when multiplied by 5 is 220x, and then we've got a 22 squared, which is 484, which when multiplied by 5 gives you a minus 2420, and then I've got a minus 5x squared. And then finally, to finish that off, you can then see, if I write the final line, the 98x and the 220x will add up to give you the 318x as required. Okay, 6 marks for that part. So we're analysing the energies correctly, give you a method mark and an answer mark. But then applying the conservation of energy will give you a method mark. And again, if all 3 terms are correct, you will also get accuracy marks as well. And that will then depend on how much of it is correct. And then the simplification down gives you the final result. So there are your 6 marks. Part B, it said explain why x must be greater than 22 for part A to be valid. Well, if it's not greater than 22, there is no extension in the elastic string, and so your analysis of energies would not apply. So the key thing is to say that x has got to be greater than 22 for there to be a tension, an extension tension in the elastic string, and that will give you that 1 mark. Part C then says find the maximum value of x. So in other words, looking back at the diagram, it's the lowest point to which it will fall. Well, at its lowest point, v must equal 0. That is the key thing. So you need to say in part C that at max v must equal 0, which in turn implies that 5x squared minus 318x plus 2420 must equal 0. It's then up to you as to what method you use to solve that quadratic. Probably have to apply the formula. So if you apply the formula, you'll get x equals minus b, so that's 318, plus or minus square root of b squared. So you can see it's just going to be 318 squared minus 4 times 5 times 2420 all over twice a, which will be 10, 2 times 5, and that gives you an answer of 54.76 or 8.84. But of course this one here is less than 22, so that one gets ignored, and so the only answer we've got is 54.8 meters. Four marks for that part. So again, stating that v has to equal 0 would give you a method mark there. An appropriate method for solving the quadratic. For obtaining the solutions, and then for reducing it down to only one of those two answers gives you another mark. You need to give a reason, i.e. the fact it's less than 22. Okay, that was the key thing. Right, on to part D. Question goes on. We've got to show that the speed of the bungee jump is a maximum when x equals 31.8. Well, the speed is a maximum when a is equal to 0, when the acceleration is 0. So you need to say something like v max implies a is equal to 0. Now, the acceleration will be naught when the tension equals the extension, because the key thing is you've got the tension acting upwards and the weight acting downwards, and it's the point at which those are in equilibrium that will give you A equal to naught. So if T is equal to W, we know the tension is given by lambda extension over L. So that is 1078. The extension is given by x minus 22 over L, which is 22. And that must equal 49 G. Okay. And we want x out of this expression. So we divide through by the 22. Well, basically we've just got to fiddle this around, haven't we? So x will equal 22 plus 49 times 22 over 1078. And that will give you a value of x of 31.8. I assume that's in meters. Yeah, just spotted the fact I missed out the G in there, didn't I, from the line above. Yeah. 49 times 22 is 1078, as we said earlier, so this just becomes G, which added on to the 22 gives you the 31.8. 3 marks for that. Again, a method mark for realising the tension has to equal the weight when the acceleration equals naught. And then an accuracy mark for that expression, and then for getting the correct value of x gives you the 3rd mark. And finally, in part 2 of the question, it then says hence find the maximum speed. Well, we know the value of x, so if we use the expression from part A, the 5v squared equals 318x minus 5x squared minus 2420, we can write down the fact that v squared must equal 318 lots of x, so that's times through 31.8 over 5 minus 5 times 31.8 squared minus 2420, and then we can square root that result, so v will end up being 22.96. In other words, near enough, 23.0 meters per second. That would be to 3 significant figures. Again, 2 marks. A method mark for realising that you've got to substitute the 31.8 into the given expression at the beginning of the question, and then an accuracy mark for your answer. Well, hopefully that solution has proved to be of help to you. For further assistance, please go to the Further Maths Support Programme website.